I want to find the interval of convergence for the power series. First one we're going to have is a sum from n equals 0 to infinity, x over 4 to the n. So here we have to use the ratio test. We'll take the limit as n approaches infinity. We're going to look at the n plus first term over the nth term. We're going to divide that, and we want this to be less than 1. Okay, so here the only difference is a factor of x over 4. So we'll have the limit as n approaches infinity, the absolute value of x over 4. We want that to be less than 1. But notice that this does not depend on n. X over 4 does not depend on n. So we can remove this and have x over 4 less than 1. That means absolute value of x is less than 4. So x has to be between -4 and 4. Now we have to test the endpoints. So we have to see if I plug in x equals -4 or 4, does it converge? So let's just keep that in mind. If I plug in -4, I have -4 over 4, so that would be -1 to the n. Versus if I plug in x equals 4, I get 1 to the n. In both cases, the ratio is not in the interval from -1 to 1, because this is when it converges for the geometric series. They're both at the endpoints. So both -1 and 1 are at the endpoints, which we do not include in order for it to converge. So obviously that diverges. So we're just going to leave it as it is. Next, we have the sum from n equals 1 to infinity, -1 to the n times x to the n over n. So this is a good little trick. Whenever you use a ratio test, for anything to the power of n, we know that all that we're going to be left with when we divide is -1 times x here. Okay, because basically you would have -1 to the n, x to the n over, n plus first, over -1 to the n times x to the n. So all you'll be left with is -1 times x. So this is a nice little shortcut that saves us a lot of time. Okay, but now we would have n plus 1, so we put n plus 1, and then you would have, 1 over n. Okay, so this is the part that was simplified from this part, okay? So if you want, you can use this shortcut, or you can just do it the other way. So we want this absolute value to be less than 1. So the way we're going to do this is we're going to line these up, so the top and the bottom will be multiplied. So we have a -1. And really, whenever you have a -1, because you have the absolute value, that's just going to be positive. So, because I don't feel like it, I'm just going to say, get rid of the -1. Doesn't matter. So we have n times x over, now you multiply these two, that would be n plus 1. So you want that thing to be less than 1. And the x can come out. And so the limit as n approaches infinity, n over n plus 1, well, that's just going to be 1. So now you have the absolute value of x being less than 1, which means that x has to be between -1 and 1. All that leaves us to do is to test the endpoints. So we have to test x equals -1 and x equals 1. Okay, if I plug in x equals -1, I have -1 to the n times -1 to the n all over n. And so this will just be -1 to the 2n over n, which is the same thing as -1 squared raised to the n power over n. And that's just 1 to the n over n, but we know that's just 1 over n. This is the harmonic series, so that diverges. So we do not want to include -1. If we have x equals 1, that turns into negative 1 to the n times 1 to the n over n. 1 to the n is just 1, so that's just negative 1 to the n over n. Now we know that this is an alternating series, so we would have to check the conditions for the alternating series. It has to be decreasing. It has to, the limit has to, the limit has to go to 0. So let's check that. Oh, and also a sub n has to be positive, right? So you would just have like negative 1 to the n times 1 over n, and this part would be the a sub n. Clearly 1 over n is positive since we're looking from 1 to infinity, so this is good. 1 over n goes to 0, that's obvious, and also 1 over n decreases. So all three conditions are met for the alternating series test. Therefore, we do want to include x equals 1 because it's going to converge. So now we go back to our work here and say that we do want to include x equals 1. Okay, next one, we have the sum from n equals 1 to infinity, negative 1 to the n plus 1 times x to the n, all over 4 to the n. Now if we apply the trick, all that's left is negative 1, x, and 4 in the denominator. So you would have the limit as n approaches infinity of this thing. You wanted it to be less than 1, so that would just be negative x over 4, the absolute value, limit as n approaches infinity. We know that this does not depend on n, and the negative is going to cancel out and be positive. So we'll just have the absolute value of x over 4 being less than 1. So the absolute value of x is less than 4, which means x has to be between negative 4 and 4. Now we have to test the endpoints. If x is 4, we have negative 1 to the n plus 1 times 4 to the n over 4 to the n, which is just negative 1 to the n plus 1. And we know that this limit does not go to 0, so therefore automatically diverges. If x is negative 4, we have negative 1 to the n plus 1 times negative 4 to the n over 4 to the n. And you can bring out the, you can factor out the exponent n and have this. And so this would just be negative 1 to the n plus 1 times negative 1 to the n, which is just negative 1 to the n plus 2. And this does not go to 0, so it diverges. So that means we do not want to include it. So the interval is from negative 4 to 4.